Good morning. Welcome to another Random Code stream. I'm going to get into it right away after I have another drink of coffee. All right, so what I want to concentrate on, there are two bugs. There could be more, but there's two bugs that I know of that are in Rocks. Rocks is this mocking library that I maintain that basically allows you to create mocks in .NET, but it does it all through source generators. So that's the one key difference from a lot of the popular ones that are out there. So the two bugs that I have, one of them I actually found by trying to look at other bugs that other libraries have. So this one was found, this is the one I'm going to work on, is because I was looking at something in dynamic data. It's a library that exists out there in NuGet. And this one, which I'll tackle next, this one came from an issue and end substitute. So I was just playing, and this isn't an app that you can, or a repository you can get. This is me just looking at issues and going, well, do I have the same problems? This one that's in MOQ is interesting because it basically says that if you try to set up expectations on a generic method by the type, if one derives from the other or something like that, it wasn't counting them correctly. Rocks handles it just fine, no problem. So it's kind of like, oh, okay, I'm not trying to compete here per se, but sort of. I mean, I do want to build something that is as good as it possibly can be. And so if another framework has an issue with something and I don't, it's like, well, that's good. But I also found an issue that isn't another framework and substitute. So, my library can still improve. There was one that, this is actually just one of these cases where you're trying to mock something and the constructor is calling virtual members, and that's always problematic. It ends up that the subtype, how does this work? Example. So your constructor calls a virtual method, but the mock type that I create is trying to set expectations. Well, because this is virtual, the way I automatically set up hooks to want to call it. In fact, if I go to here, we can look at the, no, not that. We want to do this. If I look at the generated code, and this is something I got to fix. It's not a big deal, but I got to make sure I make this note about a bug. It's a very, very minor formatting bug. This should be like over here aligned. It just looks weird when you do it this way. But you can see, with A, that I'm assuming expectations has already been set. So actually, the more I talk about this, it might be the case where I would want to actually do a question mark and say, well, maybe expectations haven't been set just yet. That would make the code slightly, just a tad bit slower. But that way it would be a little bit safer to make sure that things are handled correctly with the expectations. And then you could do something with calling a virtual member, because expectations aren't set until after the constructor, which we'll call your base constructor, is set. But that's a problem with trying to handle virtuals in constructors. You should really, really not do that. Because of the way things are called and ordered, and you may not have something set up that you thought was in time. So you really got to be careful with doing virtuals, because like you can see, things can get overridden in ways and you didn't expect that. So you should really not do that in the first place. So anyway, there's another one. Yeah, 866. This one, this type from whatever library has an internal member, so you can't mock it. It doesn't matter which mocking framework you would use because you don't have it's an interface, so you have to implement all the members, and that one's not a default, doesn't have a default implementation. So really what that does is it says this interface, you can use types that derive from it, but you can't create your own types that derive from it because you don't have access to the internal member. So the thing with rocks is here I catch that right away, and I tell you as the type has no members that can be overridden. That's not true. Did I remove that type? Oh, I might have just even removed the whole type because I didn't want to keep it around for some reason. Huh. Okay. But in any event, that's right, because that was from that library. So yeah, it doesn't know what that type is, but now it's saying it has inaccessible abstract members, and we can't mock it. So anyway, it was kind of cool to check out another framework and get some feedback on my framework in an indirect way. You know, the problem with rooting out issues with the library is it's really got to be used in ways you didn't expect. You know, get some testing from people that try things and go, hey, wait a minute, this didn't work. And that's why on my day job, or the project I was on last year, I asked if we could use rocks if we wanted to set up mocks. And I put in the caveat of, if we ever run into a problem that we can't get around, I will spend the time off hours updating to using something like MOQ or whatever. And fortunately, we never did. I think we ended up finding over the course of 6 months 2 issues with rocks, but both of them were really, really small and easy to fix, and we could get around them. So it wasn't, you know, they were not showstoppers. So, but the ones that I'm going to work on now, the one that I found from another library by referencing it, and then one that I found because it's similar to a bug and end substitute, those cannot be worked around, and they are valid issues, and I don't think they're going to be easy. So I'm going to get my music going. So we have something in the background. So let's look at the first issue that I'm going to tackle. So this was found because, is this the one? No. This is not the one. This is the one I'll do later. That comes later. This is the one that comes from, dynamic data. And the problem is that there's a base interface, these 2 generics, and there's a refresh method where a T key is passed into IEnumerable. And then there's a interface that derives from iCache updater. And it also declares a refresh method, but it is IEnumerable of TObject. This is just overloading, but it's perfectly valid. There's nothing wrong with that. These 2 types are different types. Okay. And actually, if you look, I have a test here to go, but you can see here, well, actually, this isn't quite the case that rocks would do, because rocks, we don't close the generic. We always leave them open now. And so we would say this, and then we got to put the constraints on it, which rocks would do, like that. And now let's implement it. And so you'll see now it'll do these 2. Okay. Now here's the interesting thing. I didn't think of this before. Var x is equal to new x of string and string. Well, if I say x dot and I say refresh, and I give it an array of strings, it's going to go, call is ambiguous. That's not Rox's problem, though. There's no way that Rox could ever handle that. Now, if I say GUID, then they're 2 different types, and then it knows which one to call. But this is also something to be a little careful of if you actually create designs like this, because you could put your users into a situation where it's like, well, which one would they actually call? So generics are fun. But this is a valid case. This is something that Rock should effectively generate something like this. And for whatever reason, it's not generating both of them. Which one is it generating? It is generating the T object one. I think that's the one from the derived one. Yeah, and it's missing the one from the base. So we got to figure out why it's missing it from the base and then make sure that it's actually generating it. And so one of the fun things about Rocks is that it's basically got to figure out all of the methods that you could implement. And so it doesn't have the full-blown, what are all the distinct overloads is really what it's looking for. That is quite complicated. And I don't think there's anything in Roslyn to tell you that. That would be so nice if there was a way to say, here's a type, Roslyn. Tell me all of the distinct methods I could override, I could implement. Just like what you saw with that refactoring or that, that refactoring that's in Visual Studio. And even that one is not 100%. I have seen it where I've tried to in the past use it as I'm trying to fix bugs in Rocks, and it doesn't implement all of the members that it should, or it doesn't do it quite correctly. So, it's overloading, from what I remember people on the C# compiler team saying, is one of the most complicated features in C#. It is fraught with exceptional cases, and you got to be really, really careful to handle that correctly. So if there's ever a feature that in any way touches the concept of changing overloading or affecting overloading in C#, I've heard they actually put they forced to have even more reviews on it because it's so complicated, which that also begs the question, if it's so complicated, maybe that was something that we shouldn't have done. But because there are languages that don't allow overloading. Eiffel is one of them. Every method has to have a different name. Now, of course, somebody could say that's ridiculous, and I would totally understand that. But it does make things much simpler because then you don't have any overloading issues to worry about. So in any event, we got to figure out now why we're not getting all of the methods that we should. So, yeah, here we go. And this is an interface, so we're going to go look at interfaces. And so the first thing we do is we get all the methods that are on the type that we're given. Okay. And so that's fine. Now what we want to do is go through all of the, yes, I do, all the interfaces and see somewhere in here this matcher is not working exactly the way, I think it's this match method. And that's an extension that I made, I believe. Did I? Method symbol extensions. Yes. So does this match? So somehow in here, this matcher is not quite working out the same way that I thought it would. That's where the culprit is, I think. But let's see what happens. So now at this point, we should have one method, right? Oh, two. Oh, that's right, because there's an add or update. That's fair. But we do get those two correctly. All right, fair enough. So now there should be one base, and that is the cache updater. Okay. And so we get one method from it. Okay. Yes, we can see it. And I bet what we're getting is there is a match. Okay, so let's stop. And let's put it on match here. Actually, let's put the breakpoint there. Okay, so now it's step in to match. So we have add or update. And our method. So this one, because the names don't match, there is no match. Okay, fine. But now we're going to have the one where the names do match, right? Right. And so this goes to here. They do match. The number of parameters matches. So we get their parameters. Oh, I'm sorry. If the type parameters length is different, then there's no match. These are the parameters themselves. Do they match? Yeah, and they both have 0. Okay. Are they arrays? Because arrays are fun. They shouldn't be. They shouldn't be ref kind or params. So the only thing we can do is get the types. Do types match? Yeah, that's where. This is one of those cases where I should have put, why didn't I just do symbol equality compare default equals self parameter type other parameter type. They don't equal. So it would be a method match none, and that would handle it. But why are we not? Why are we not using symbol equality compare? Well, let's step in and see why. Left type. I would not have done all this code if there wasn't a reason. Fully qualified format. If left type does not equal right type, but by display string. Now we know the type name sans generics are the same. Now we check each type parameter. So they both have one type parameter. See here, okay, so here's my assumption. Therefore, we can continue because comparing names like T and U is meaningless. No, it's not. It's not at all. Like we look at the type argument and we look at its type kind. It is a type parameter. So I've got two thoughts here. Why are we going through this whole rigmarole, so to speak. I don't even know what that word means. It's just a word I've used. That could come from something offensive. I have no idea. I don't know where that word comes from. But I could go through all this work where why doesn't symbol equality comparer work? It seems like it'd be easier than to go through all this. But I'm guessing there is a reason because of like nullable parameters or, do these equal name type symbol and right is that. Otherwise, we fall right into symbol equality. Why do we... There is an include nullability. Considering the reference type and the same nullable reference type are not equal. So maybe that's what we do. I'm kind of wondering... if what we should be doing is just saying here well, we can't compare the methods themselves. I get that. But what we can do and I get the array and the ref are a little different. But once we get down here, yeah, these are type parameters, so we don't need to compare them. Yes, we do. We absolutely need to compare them. So, okay, this is the last chance, is that we look at the return types. So here, I think we would want to do if symbol equality compare include nullability equals self parameter type other parameter type, we continue. Otherwise, return method match none. This is kind of the guessing game I'm doing right now. And then we would do the same thing down here, which is to say return self return type other return type method match exact method match differ by return type only. Now, the first thing I want to do is run it against this test. And hopefully I get a difference in the code rather than a compilation error. And that it picks up that that other method should have been included, and it does. Well, I think. So now it does the T key one, because that's from the first type. So there's now a third there. T object, but now we have T key. Okay, so that's good. And so basically it's picked up that it needs that new method. Now, before I move any farther on this, let's actually run all of the tests on rocks here. Because this may have broken, if we get one failure, that's okay. If we get a lot of failures, that means we've broken other assumptions that I'm not considering. And that's entirely possible. In fact, I would be kind of shocked if I still only have one failing test. Yeah, 8 failed. Which isn't terrible. Yeah, generate when generic parameter name changes async. That's a problem. And then nullability changes an override. Interesting. So that ended up... Oh, because... Interesting. Well, let's look at this test. So... match when methods are exact with type parameter. And so this is saying it differs in return type. And you know, here's a fun one. This is actually maybe potentially a misunderstanding that I'm doing here with my test. This return type of T is actually different than this one because these two T's could be completely different. These are two different classes, and these T's here are not the same. So what I'm getting at is if I did something like public interface IA, and I had, and then let's put this, and then I had public or just return type of T M1 of T. And this is also bogus because what it should do is just say new, right? So this is actually not the greatest code. Yeah, whatever. And now let's have an A, and let's have B and B. Okay. And now let's have a public class C that implements IA and IB. Okay. What's it barking about here? Type IB an interface list is not an interface. What do you mean it's not an interface? Of course it's an interface. Shut up. Generate overrides. Well, now let's see. Do we get the option to... Oh, wait a minute. I'm being stupid. These have default implementations. I want it to be implemented here. Implement interface. Now you notice here what I think should happen now there. And I think this is correct because it's saying these two methods and these two return types are different because the T is essentially scoped to that method. And even if you wanted to call, you know, well, okay, that's actually, hold on. I'm not doing that right either. Let's call these M there. Now this arguably is correct. Now let's get rid of like it yelling at me because... So this is one correct way of doing it. Because I guess you could say, what's the difference between these two? There isn't. They are exactly the same. And so I get why the way I was doing it weren't there 8? Yeah. Now, of course, between two classes, you can't do multiple inheritance. So I don't think this test is exactly right in terms of what it's looking for. I mean, I sort of get what I'm trying to test here. But strictly speaking, those two would be different. But where did I go with that code? Like you saw, there was an option here. If I say that. And so if I would get that they are different by return type, then what I end up generating is this. And if you look at the number of tests that are failing that are actually generator tests, these are all method symbol tests. These are ones because I changed the matcher. This is one that was already failing because I just added it. This one is because I'm overriding it, but I'm changing the name of the type parameter for reasons. I don't know why, but I am. This is probably from a library that I found that does this. And so what is happening here when I do this? Yeah, it's ending up now making this method here. Which is not what we want. Right? I mean, if I take this and I plop it up here, and I have a public class X that derives from M of A, except that would have to be A. Oh, whatever. Generate overrides. You see, it correctly picks just one. You wouldn't do this one because they're not two distinct methods. They are the same ones. Now, if I didn't do override here and I said virtual, you see it says now it's hiding. So in the interest of not screwing up everything I've done in my life, I have an interesting conundrum here, which is I can't use symbol equality compare here. So that unfortunately we can't do. But in this do types match, if they are type parameters, see, I get what we're doing here is we're trying to say, well, if they're closed, meaning I've actually provided a type, then we want to compare, do those types match? Here's the interesting thing. This is kind of a holdover because Rocks doesn't let you mock closed generic types anymore. They have to be open. And it's a good thing that I changed that because that basically allows you then to create, like if I wanted to mock iList of T, what I was doing is I was forcing you to like say I want to mock iList of string or iList of object or iList of int. Now you say type of iList and you just leave the generic open. That way, when you're declaring your expectations, you can state there what the generic should be in that case. So it's much more flexible that way. But the problem is we'll never hit this. Well, not necessarily. Because it's entirely possible that there could just be a definition of something that actually has like list of string there. So that's not true. So we can't just remove that here. But they're not meaningless. I think that's the problem I'm having here, is that they're not meaningless. So let's this is such careful surgery. Okay, so named left and named right. It has one type argument. So if I grab this and I say 0, they don't equal. Which would be true, because they don't equal. But the only way to get here is either one, you're doing this for return types, or two, you're running into the case I have here, which is their parameters. And so the name matched, the number of parameters to the method matched, the types matched with no generic options. So they both said am I enumerable without the generic type. And yes, we have to be recursive about it. This is the case, though, that I need to handle. If they are type parameters, the reason I'm doing original definition is, I thought went through, is I'm trying to look at where it was originally defined. But that might not even be considered correct. So we want to do something here to say, we know in this case they're not type parameters. So they're actual types. And so arguably here, we don't even need to be recursive. We could just say, well, and let it do the heavy lifting. What would that do with our tests? I don't think this would be quite right. And the reason why is just because what I have on my comment up above, which needs to be recursive. Yeah, to fail. This is not a type parameter, but it is using type parameters within it. And what this is saying now is that there is no match. But again, is that quite true? Yeah, I'm going to have to do some... and then we don't want these to have implementations. And now if I have public class, they could arguably be implemented by the same because they are arguably the same. But I don't know if I agree with that. The reason why I don't know if I agree with that is because are those truly the same? I mean, arguably they are. And so what are we failing on here? Oh, I already removed that. We're saying that they don't match. But so we do if they differ by return type, then we do explicit implementation to handle that case. Okay. So this isn't going to work either. So, yeah, we have a conundrum. We have a conundrum in that well, they're both not type parameters, but we eventually come into the spot where we think that well, we know that we get to where they're T object and T key. We think it's meaningless. We fall through. We're going to return true, which means do the types match? We're going to say yes, they're true. And so then we eventually fall through to here and say that the return types do match. And so we say it's an exact match. And that's why we don't now, if we know they're not type parameters, I just don't think, though, that we can come through here and say that we can just ignore them. But I don't know how to handle because I get the case that I had here, where it's like recursive. Yeah. We have to dig in and find that these two, that it's meaningless. But again, I don't know if these tests are actually 100% correct in what I'm trying to solve here. Like, I want a test that says what if these are on the same type? And the type parameter is defined at the class level, not the method level. Because I can sort of kind of see what I'm doing here in that case it wouldn't matter. But if they're coming from the method definition, then yeah, it is arbitrary. If it's coming from the type definition, that's different. That's why I was kind of wondering, where are these being defined? The original if I knew where it was originally defined and if the symbol was a type, I wonder if that would matter. No, we don't want to do it here because we'd never catch it. We want to do it here. Yeah, this is really the fun, tricky stuff. And I so wish I could just have a method that told me all this. For these set of types, even if it's a class or a class and interface or whatever, tell me all the things that I could implement. And I don't care if they're explicit or not, because I can handle that. I can define that. I just need something to do this algorithm for me. You know? So we already got the T. Okay. So we got here. So if I do the left and I say original definition containing symbol. And now what about named right? They're both, well, okay, I guess. Yeah, I get, okay, fine. Because they are both defined in source updater. They're not defined in there. But the one that's on object, the one that's on key, is from here, but now it's going to be down here, and so it would think the key is actually from source updater, not the one here. I feel like I should go to the Discord channel and ask again. Dear Bertie Sanders, I am here to ask, here to ask once again, is there a way to say, given a type, what are all the members that can be overridden? God, that would be so nice. Because that's what I want. If I had that, I think that would eliminate a fair amount of code that I have, especially like here. I think that would almost eliminate half of this, if not more, if I could find something like that. I mean, sort of. There's a special case I have here with the use of the object symbol and stuff like that. But even then, I'm basically saying I want to use that refactoring. But I don't think that refactoring is 100% bulletproof. And these are both type kind. Yep, they're both going to be type parameters. If they're not type parameters, then we recursively go through our stuff. And this is I don't know if that's true, because what if they use type parameters? I'm guessing. Well, yeah, what happens in this case? Wait a minute, stop. Okay, so now type arguments. One its type kind is a class. So it is not strictly a type parameter, but it is a class. Sense make. Okay. If they are type parameters, yeah, and the problem is that we just are looking at the type symbols. Excuse me. Part of me is thinking there needs to be a context that's carried along with this, because we're just getting the types from two methods that we want to match. And the only reason that we're asking to match is because they are on two different types. Well, no, not necessarily. We could have the case where you could have this refresh, I bet the same problem would show up here as well. If we did that and we didn't derive from cache updater, it wouldn't recognize that those two are different. So we have to recognize that these are different and generate accordingly. But like you saw in some of the other cases, if you have like two interfaces that are from two separate types, like this one derives from this one. But if I had these two on two different interfaces, and then I was trying to have a third one that was a composition of those two through inheritance, I don't know if you could tell the difference. I don't know. This is a struggle. So I think at this point I'm going to stop because I need to run some errands this morning. I do know where this problem lies. It's right here. It's kind of what I expected. But this is becoming very thorny. So what I want to do is let's create some notes. Look to see if there's any way to get a list of members that can be overridden from a type that can be overridden from Roslyn. That would make things so much easier in the long run. Right? Assuming we can't, we need to find a way to handle parameter matching correctly for this case. And then what I want to do is I want to put it in my rocks, docs, notes. 351. I typically will keep notes like that if I'm trying to find an issue to something and I'm running into a problem. I guess at the end of the day, I feel like I really didn't accomplish much, but I don't want to just rush this for the sake of finishing this. So, as you saw, if I was doing a couple changes here and there and trying things, and that would break other things and other assumptions. And I really don't want to do that. So, because this has always come back and been really tricky. And maybe I can ask the community to say, is there ways that given a type, it can be a name type symbol, but given a type, to say, give me all the members that, and it's, I got to be really careful about how I ask the question because people are picky and I get why. If I say, well, an interface has a default member on it, technically I don't have to override that. Technically I don't have to implement it. But what I want is give me all the members that I could implement, that I could override or that I could implement. And if I can find that, I would gladly take the hours of work to put that into rocks and use that instead of what I have. Because I think that would make things so much easier in the long run. But it would have to be something that now I'm depending upon something from Roslyn to quote unquote work correctly. And I don't know if that's something that I'm going to get as a guarantee. And so now I'm going to be left with coming back to here and saying, okay, how do I tell the difference between this and this such that they are different? I can see they are. You know they are. They're going to be two different type parameters. But the problem is that I have cases where, it becomes complicated. And this S and this Q they can be done as the same. If these were on, because the type parameters are defined on, look at the symbol type original definition type kind. If it's a method, we don't care. But if it's a type, we do care. I think that might be it. Maybe. So let's run this test. It is a type parameter. It is TObject. But if we look at the original definition, containing symbol type kind, it is a named type. Oh, sorry, that's wrong. I want named right here. Not named left. That's also named type. Okay, that's fine. If I come here and I say run this bad boy, name left, it's a method. Now, that's because it's B here. But that doesn't matter. That proved my point anyway, because it's defined on the method. I think I found my way out. So I've got two options here. Okay. We want to grab that. If kind is a method, then we don't care. For both, then we don't care. But if it's something like named type, then if the names are different, that is different. I mean, sort of. I don't think this is 100% true, but I think something like this would help. Because if those type parameters are defined on the type, then if those two names are different, that matters. And then they are different. There is no match. But if the type if the containing symbol of the type parameter is method, and the whole reason we drove into this is because we were comparing two methods, then I don't... Or maybe we just look positionally. I don't know if you can, if there's an easy way to say, where was this positionally? Because like we saw with another test earlier, if you change the name of the generic type, of the type parameter in an override, it's effectively meaningless. I don't know where I had that. It's somewhere. It was somewhere in here. Yeah, here. So I want to keep that in mind, because I'm saying if I essentially renamed it, these two are effectively the same, and that's why we would get a match. But yeah, again, if we have two methods that have the same number of type parameters, it starts getting really tricky. But I think we're closer to a solution here. I do have to go and do some other things, but I think if we can use this one trick, can make a clickbait thing out of this. You didn't know this one trick. .NET developers don't want you to know this. Do some crap like that. I will never do that. Maybe it's an April Fool's joke, but I would never do that. But I think if we can look at kind, and they are defined on the type, then the names do matter. If they are not, if they're defined on the method, then are they the same parameters positionally? The name doesn't matter. It's the position of where that type parameter exists. I think that's what matters. So I will have to look at that maybe tomorrow morning, because I got to run some errands. I want to do an Outer Wilds stream this afternoon. And then tonight, my wife and I are going out on a date, dinner and a movie. So tomorrow morning, I may dive into this more and see if I can. I'm also going to ask sometime this afternoon or whatever, and just say, hey, to the Roslyn community, is there something here that you can use to say, given a type, it can tell you all of the members that could be overridden, implemented, however you want to say it. That would be cool. But it has to be 100% reliable. And I don't care if it tells me, hey, these two are like paired because they came from an interface, so they have to be explicitly implemented. As long as it would say, here's the list of things I could use, so I could basically make my own type derived from it. I know that's somewhat special case, but it's also used for things like what you would have in Visual Studio. But then I think that's a refactoring that's in a different place. And I don't know if that has the same kind of, this will always give you the right answer, because I've noticed sometimes it doesn't. and I can't have that. It has to be correct. So I don't really know if I want to truly pursue that. I'd rather have something that I own because I've been getting it to work, and I think I can get it to work here. So with that, I am going to stop the stream, but I am going to come back tomorrow morning in all likelihood and do another live coding stream and try to address this and see if I can get this to finally work. So if you're watching either now or in the future and you haven't subscribed to the channel yet, please do so. I would greatly appreciate it. I'm trying to get to 1,000 subscribers. So I'm getting closer, but the more, any more subscribers I can get would help. So thank you in advance for doing that. Again, I will be doing probably a Outer Wilds stream this afternoon and also tomorrow afternoon and or evening. So with that, I'm going to stop the stream. Thank you all for watching. Take care, and I hope to see you in the future.